In this example, we're using a comparison to show that a series converges. So we want to show that it's bounded by another sequence that actually converges. And so if we're looking at 1 over n plus 1 squared, so this is 1 over 4, 1 over 9, etc. 1 over n plus 1 squared is less than 1 over n times n plus 1, because we're making the denominator smaller. And 1 over n times n plus 1 is 1 over n minus 1 over n plus 1. This is something we saw directly earlier. And so the sum from 1 to k, the partial sum of 1 over n plus 1 squared, is less than the partial sum, and going from 1 to k, of 1 over n times n plus 1. And that is 1 over 1 minus 1 over 2 plus 1 over 2 minus 1 over 3, etc. Altogether, the terms collapse, and then we have that this partial sum is actually equal to 1 minus 1 over k plus 1. And so all these partial sums are bounded, and this sequence therefore does converge by proposition 4, or we saw that even directly. And that means that these partial sums are also bounded, and so they also converge to something. We don't actually know what number this converges to from this calculation, but we do know it converges to something by proposition 4.